So let's see the basics of trigonometric ratios. Okay, so there are basically three types of trigonometric ratios. One is sine, the other is cosine, and the third one is tangent. So sine is abbreviated as, written short as SIN. Okay, cosine is written in short form as COS, and tangent is written in short form as TAN. Okay, tangent, TAN. So the sine, cosine, and tangent, these are the basic three trigonometric ratios, and we have other three trigonometric ratios which are basically the inverse, or we can say the reciprocal of these. Okay, not the inverse, but the reciprocal of these trigonometric ratios. Okay, we'll see that thing later on. But first of all, let's memorize like how, or let's see how to remember like how to find the sine of any angle or the cos of any angle and the tan of any angle, because sine, cosine, and tangent are like functions. We can say, normally we say trigonometric ratios, but we can also say they are, consider them as functions. Okay, and sine, cosine, and tangent like work on angles. Okay, so the input to these functions are basically angles, and we normally talk about this in a right angle triangle. Suppose if we take a right triangle like this. Okay, let's say if this is the right triangle. Okay, so suppose this is the right triangle and this is the right angle, and suppose we're talking about this angle. Okay, theta. Let's represent this angle as theta. Okay, you can use any variable like alpha, beta, gamma, theta, or x, y, z, whatever. Okay, let's just choose a Greek variable theta, which is most like the most general variable for the angle. Okay, we can say normally used. So basically, if we see this angle theta, so suppose the side lengths are, suppose this side length is A, this side length is B, means that length of this side, okay, is A, and the length of this side is B, and the length of this side is C. Okay, so we will learn about how to find the trigonometric ratios of any of these, okay, sine, cosine, tangent, for like in like what's the like we can say abbreviation to remember, or what's the thing that we remember. Okay, so there's one rule. Okay, sine, SOH, so ka toa. Now this seems to be like something very weird. Okay, like if you might be seeing this thing for the first time. So basically this is like, this S, C, and T basically are the first letters of this sine, cosine, and tangent. Okay, and O here, O actually means opposite side. Okay, O here means opposite sides, and like this O and this O. Okay, and A basically means adjacent side. Okay, adjacent, and H basically means, like I say, as A, H basically means hypotenuse. So we must know like what is the hypotenuse. First of all, hypotenuse is that side which is opposite to the right angle. Okay, in a right triangle basically. So this side C, this is the hypotenuse. Okay, because this is opposite to the right angle. Okay, and then what is the opposite side? So the opposite side with the, which is basically the side opposite to the angle in reference. Okay, if we're talking about this angle theta, like we have to find sine of the theta, so the opposite side O, opposite side to this angle theta will be this one, which is this. Okay, for this angle theta. So we can say in this case, when you're talking about this angle theta, this is the opposite side. Okay, and finally the adjacent is the angle which is left, the side which is left. Okay, this is just adjacent, this side is adjacent to this. We may say this side is also adjacent. Okay, but this is actually hypotenuse. Okay, not the adjacent we need right now, we are referring to. Okay, so this is the adjacent side. Okay, adjacent side. Okay, this is the hypotenuse, this is the, so now if we say what is the sine of this angle theta, sine of the angle theta. Okay, let me write the theta again, sorry. So the sine of this angle theta, sine of this angle theta, sine is what we see, sine is actually the ratio of the opposite over the hypotenuse. Okay, that's how we read this. Okay, so ka2, so sine is the ratio of opposite over hypotenuse. Okay, so opposite comes first, so opposite is basically the A. Okay, so we write it like opposite over hypotenuse. I'm just writing this because we're doing it for the first time. So this is like opposite is A and the hypotenuse is C, so that's A over C. Okay, So now when we say what is cosine of the theta for the same angle, so cosine is what, when we read this thing again, cosine CAH ka, so ka tova. So this ka C is like cosine, and this is the ratio of adjacent over hypotenuse, okay? And we know adjacent over hypotenuse. So adjacent is what? This is the side length B, okay, and the hypotenuse is the side length C. So these are two ratios, okay, sine and cosine. And then comes the tangent, okay? Tangent. So tan of the angle theta, that will be basically, tangent is what? Tangent is 2r. You know, tangent is opposite over adjacent. Let's write this thing just as a formula, okay? This is like a formula, okay, for the ratio. And so what is the opposite side? Opposite is like A. And what is the adjacent? Adjacent is B. So that's A over B, okay? So this is how we can say. So for example, suppose if we have a rectangle like this, okay? If we have a very famous rectangle, you know, the very basic one, we know that if a right triangle has a side length whose hypotenuse is 5, and the base, and the other two sides, and suppose this is 4 and this is 3, you know, we know. So this is the right triangle, suppose, and we have to find the sine of theta, the cosine of theta, and the tangent of theta for this particular triangle, which is the right triangle basically. So we can say sine of the theta for this triangle, since sine theta is what? Opposite, you know, opposite over hypotenuse. So okay, so that's 3 over 5. That's the value, okay? 3 over 5, that's the value for sine theta for this particular triangle, okay? And then what's the cosine of theta? Cosine of theta for this triangle would be, cosine is CAH, so cosine is adjacent over hypotenuse. So adjacent is like 4 and hypotenuse is 5 only, so that's 4 over 5. So that's the value of cosine of theta, okay, you know? And then there comes the tan of theta, okay? So tan of theta for this particular triangle would be, tan of theta is opposite over adjacent. So opposite, you know, is 3 and adjacent is 4, you know? So that's 3 over 4. So this is the most simplest way when we are given triangle and we have to find the value of sine, cosine, or the tangent, okay, of any angle, okay? Now suppose if I just change it, okay, a little bit, just to make it a little bit more interesting, okay? Suppose we're given a triangle like this, okay, you know, the same triangle, you know, same triangle. I'm not changing triangle, even though the diagram is not up to scale, but suppose the same triangle, okay, fine. And suppose this angle is alpha, okay, you know, and now we have to find this sine of the alpha and the cosine of the alpha and the tangent of the alpha, okay? So I want you to first of all give it a go, okay? Pause this video over here and then find what is the value for the sine of the alpha, which was the ratio basically, as a fraction only, sine of alpha and the cosine of the alpha and tangent of the alpha, okay, you know, for this thing. So I think you can pause the video over here and give it a shot, okay? So I guess you might have attempted this one on your own. So basically sine alpha is what? Sine alpha is the ratio of opposite over hypotenuse, okay? We know. So whenever you do problem like this, just write in somewhere in the side of the paper, okay, on somewhere like this thing, you know. So ka to, it's a bit difficult to write at the edges, you know, so you know, so this is like this. So ka to, also sine is opposite over hypotenuse. Remember, we're gonna remember from this, okay? So opposite is what? Opposite for this angle, okay, basically. So opposite for this angle is opposite for this angle is this 4, okay, you know. Just you can mark over here, okay? This is the opposite, like this, mark the O, okay, you know, you remember O. And this is the angle opposite, side opposite to the right angle is hypotenuse, okay, and side opposite, and then the side left is adjacent, okay? So opposite is always the opposite to the angle in reference, okay, and hypotenuse is the most easiest to find, the side opposite to the right angle, opposite to the right angle, and finally the leftover side is the adjacent, okay? This is the adjacent to this side. So sine of the alpha is opposite over hypotenuse. So opposite is 4 and hypotenuse is 5, so that's 4/5, okay? and then cosine of the alpha, you see, cosine of the alpha, you see, is actually so cosine is what? Adjacent over hypotenuse. So adjacent is 3 and the hypotenuse is 5, okay, so that's 3/5, okay. And finally the tan of the alpha, tan alpha is what? Tan of the angle is what? Tan is opposite over adjacent, so tan of the alpha would be the opposite to this alpha is 4 and the adjacent is 3, so that's 4/3, okay. So I think that's enough for this video. I'll share this page in the link as if you want the PDF of this, okay. And we'll see in the next video the conclusion of this thing, like what it leads to actually, you know, because we'll see an interesting result coming from this little from this simple example, okay. So stay tuned, see you soon, okay, bye.